Hi everyone, my name is Tiffany Wade. This presentation is going to cover mass wasting hazards in California. When we talked about mass wasting earlier in the semester in our lectures, we talked about kind of the what and the how, and I really wanted to dive a little deeper into the effects and what happens, especially in California, what happens to the areas and the people that are affected by these mass wasting events. Okay, so for this presentation, I'm going to focus on three types of mass wasting. Um, rock and debris falls, where the rock falls, it detaches and falls away from the parent rock. Mudslides, where saturated soil flows down in a kind of a liquid state down a slope. And then landslides, and the one that I will be discussing will be a rotational slide where the failure causes everything to go with it. It's not a very uniform slide. So there's four main contributing factors to mass wasting. The first, increased slope steepness. Basically, the steeper the slope, the more likely we are to have a mass wasting event. If you look at the picture or the background here, the steep rock faces, that's where we're going to see rock falls, rock slides, stuff like that. Number two, increased precipitation. Water, is a great lubricant. When we get water to saturate the soil, it helps, especially when we get a lot at one time. It can destabilize the topsoil, which makes landslides, mud flows, stuff like that much more likely, especially on steeper slopes. Number three, lack of vegetation. When we get, California is prone to wildfires in general. Over the last 10 to 15 years, we've gotten some very catastrophic wildfires that have completely removed vegetation from very large areas of the state. And when you don't have that vegetation there, the root systems aren't there to help keep everything in place. As hot as these fires are burning, we are losing the very fine fibers of the roots, and sometimes just the roots entirely. Some of these areas are burning so hot that there's nothing left. It's just ash. So we're losing all the stabilization that vegetation brings to the landscape. And then number four, earthquakes. Earthquakes can help destabilize things like, already unstable rock faces. They can, areas that are right on the cusp of being stable or not. The friction is just barely keeping things in place. And an earthquake could be just enough to help push it over the edge. So here we have rock falls, within Yosemite Valley. Yosemite Valley is an iconic area. People from throughout the world visit it every year. And part of what makes it so amazing are these massive rock faces that, people like to rock climb and take pictures on top of. But over time, weathering and the tectonic stresses have fractured the granite, making some of it unstable. Wedging from ice, precipitation that gets inside the fractures, and vegetation that grows without, on top of and within the rock face, can trigger rock falls that can have some pretty devastating effects to the area. Yosemite averages about 50 rock falls of varying sizes throughout the year. Some years more, I think it was 2018, I think, or 2017, that had like 80 rock falls that year. Some years are less than 50. The Happy Isles rockfall of 1996 dropped over 160,000 tons of rock and debris at speeds of up to 160 miles per hour. That particular fall, 11 people were injured, one was killed, and the force of the impact from the rockfall was equivalent to a 2.15 magnitude earthquake. it could be felt throughout the valley, the Yosemite Valley. One witness said that the dust that was generated from that rockfall was so extensive that it blacked out the sun for 6 minutes. Obviously not every rockfall is that large, but there is the potential. Over the history of Yosemite Valley, they've had at least 19 people killed from rockfall in the park, and attendance is only getting bigger. The park sees 4 million visitors a year, with a max capacity of the valley anywhere from 18 to 20,000 people at a time before it gets, just really compacted. So yes, you've got the hazards of known rock falls, like this happens here, and you have an increasing population coming to see this magnificent area. But we have to realize that there are hazards that are associated with this area, and that we have to be aware of that. I wanted to share this map with you. This came from the National Park Service. These are documented rock falls, within Yosemite Valley from basically the start of the park, 1857 to 2011. The valley itself has seen some very large rock falls throughout the seasons. If you look at the legend here, winter, spring, summer, fall, you've got large events in all of the seasons. And if you look, they're spread throughout the valley. And if you're familiar with the valley, you know that the bottom of the valley is where the campgrounds are, the trailheads, where all the road, the valley, the loop through the valley. So when we do have these rockfall events, there's potentially a lot of risk to people that are within the area, people camping, hiking, just sightseeing. You look at the El Cap, Glacier Point, Half Dome, very, very popular tourist sites. And whenever we have one of these rock falls, we've been very fortunate that we haven't had more people killed. So I want to move next to landslides, and I wanted to show you guys these two maps, because this really kind of covers why it's such a problem in the state. So the map on the left is a population density map. The greens, lower populations, the yellows were, kind of a moderate population. You start getting to these areas of red, it's a very dense population. And we've got the Bay Area, we've got Southern California, and we've got the Valley. If you look over on the other side, that's a landslide hazard map. And it covers a lot of the same areas of our population density, Bay Area, Southern California. We've got very large populations that are within areas that are very susceptible and, and in some places very likely to have landslides. In 2017, the Big Sur area experienced the Mud Creek landslide. It was an area along Highway 1. There was, a known slide area, but was considered pretty stable. It had a slow creep downhill, but it wasn't anything that they considered really a problem. But that winter they received a lot of rain, really persistent rain. And in January of 2017, they experienced a couple small slides that caused them to close that section of Highway 1. But in March of 2017, they had a catastrophic failure of that hillside above the highway. And that event moved more than 6 million cubic yards of material off the mountain, over the highway, and into the ocean. It added 15 acres of new coastline. And that section of highway didn't reopen for over a year. It was like 14 months. It cost over $54 million to repair. And I mean, it was kind of nice because we were able to actually put in better drainage system to try to prevent this from happening again. We were very fortunate that there wasn't anyone injured or killed on this event, because yeah, there was a quarter-mile of road that was destroyed in this. If you look at the picture here, you know, you can see just the sheer mass of material that was moved. And if you look through the picture, you can see, you know, they had to create new roads just to deal with this. Um, it was an event that, you know, they didn't expect, but isn't totally unexpected in this kind of steep terrain, heavy precipitation area. So the next event that I wanted to cover was the Montecito mudslides of 2018. This event, you know, hit three of our contributing factors: steep slopes of the Santa Ynez canyons, the, you know, heavy precipitation, and you know, lack of vegetation. So in December of 2017, the Thomas Fire started in the Ventura County area and burned over 280,000 acres. You know, the map on the top left, you know, you can see the fire perimeter. It covered a huge area. In January of 2018, the Montecito area received a little over a half an inch of rain in about a 5-minute, you know, time period, which is just an insane amount of water in a very short amount of time. And that rain, that precipitation, you know, hitting the burn area, you know, it's turned all of that soil and ash, and it's turned it into a slurry, basically. And gravity does its job, and everything heads downhill. So, you know, the community of Montecito really took the brunt of that. You know, there were reports that some areas of the mudslide were 15 feet deep. There were 23 deaths and 163 hospitalizations. Of those deaths, 2 people were just never found. Homes were lost, businesses, infrastructure, you know, city infrastructure was destroyed. There were over $400 million worth of property losses. Thousands of people were displaced, and you know, just the economic and emotional impact that the mudslide had on this community was just devastating. So here's just a side-by-side comparison of one neighborhood in Montecito. You can see that the mud flow had a very destructive path. You know, some areas were spared while others were just completely destroyed. So mass wasting happens throughout the world. You know, we're not unique in that regards. But some of the things that make California so awesome are also what makes it so prone to mass wasting events. You know, the nice picturesque steep slopes of the mountains and canyons that, you know, we like to recreate and live in increase the risk of, you know, landslides and rock falls and mud flows. You know, the coastal weather that we enjoy so much can also, you know, bring heavy rains, you know, in our winter seasons, that can, you know, exacerbate, you know, already unstable soils or slopes. You know, we have catastrophic wildfires. You know, our vegetation is, you know, has evolved to, you know, to include wildfire. Like it's part of our ecosystem. But those wildfires have been growing in size over the last few decades, and are becoming more catastrophic. And when they do come through, they're removing more and more of the vegetation, which exacerbates and, you know, helps these mass wasting events become bigger problems than they may have been before. And then, you know, we've got the San Andreas Fault that runs throughout some of the densest population areas we have in the state. You know, it runs from, you know, Southern California up through, you know, the Bay Area and continuing north. And, you know, those when they do trigger an earthquake, can, you know, push areas that were unstable and cause some of these mass wasting events. And none of this would really be a problem, except that humans are there now. We've moved in and we're continuing to grow in population, and that's where we're really seeing the problem. That's where the hazards are for us as a state and as a community. Is we're seeing homes lost and lives lost, and that's where this is becoming a problem. Science has not, our science of this is not improved enough so that we can 100% predict these events. We can guess and say this might happen. This rain might trigger something, but we don't know for sure. So really, for us as citizens of the state, and now as educated, people who are aware of these events, we need to be aware of our surroundings and know that if we're in a burned area and it's raining, we probably shouldn't be there. Just like locally, the creek fire, it's going to move into our rainy season soon, and there are going to be a lot of areas that will probably see at least small mudslides. So I ask everyone just exercise a little common sense and stay out of those areas for your own safety. But now that you guys have gone through not only Geology 1 but now this lecture, you kind of have a better understanding of the risks and the hazards associated with these types of mass wasting events.